Okay, hello everyone, welcome back to this tutorial. Now let's continue on these topics we haven't talked in last tutorial. So in last tutorial we have already discussed short connection versus long connections. Now let's start talking about a little bit on front-end applications. What is front-end applications? So it includes one is the web browser that I think you already very familiar with. It has been developed so almost all kinds of versions for different OS. For instance, you have web browser on your Android phone, Apple phones, and other phones. Not to mention that you have all kinds of web browsers on the computer or of the different operation system. The process of this web browser is that it's when you want a front end to communicate with your back end server, it's much faster to develop such a application for the customer to use their web browser to directly log onto your website. Okay, so but the cons is that it is not efficient for the hardware resource consuming application. Like you want your front-end browser to do some image processing and or deep learning stuff like that. It's almost impossible. It's very time-consuming, especially for deep learning. It will take a long time. Because if you remember that it's a web browser is works on your phone, like Android is working on the Android kind of like a virtual machine, virtual machine. So it's not directly using the hardware. So Android's phone itself running on the like a virtual machine is not efficient itself. When we design the image processing on the Android phone, we have to even we design our own application using Java, we have to use a GNI. Means the Java native interface, and to pass this algorithm deep down to the OS level, which use the C language or C++. Okay, now and not to confuse it too much. I mean the point is that web browser for doing such time-consuming and complicated task is not possible. It is very hard. It's time-consuming. It takes a long time. It's not a good choice. But in the future, we can change this situation, because in the future, remember we're talking about the home server. Our phones can connect to our home server via this Wi-Fi or internet. Okay, so we can offload this time-consuming and our hardware resource consuming application or task to our remote home server, and then the home server return the result to our cell phone. As long as we have the adequate speed of data network, the job will be very fast. Okay. The second type of the front-end application is customized application on Android, iOS, or computer. Such on I have already talked that on Android we use JavaScript and native languages like C++ using GNI. On iOS they use previously used Object-C. Now they've switched to Swift. Okay. The pros of this application is that it can maximize the hardware resource. Sorry, I missed this hardware. Okay, but not anymore. If we use the home server, this plans not anymore the plans, because no matter how strong your hardware on your Android phone, it's a small device, cannot compare to the home server, the big device. They have this. That is the computer monster, kind of like they have like a lot of GPU, and maybe you also can offload. You can also have the FPGA kind of stuff to offload more jobs from your home server. The cons is that it takes longer time of development of this kind of application on Angel. Okay, so normally it takes several months, more than 7 like us. Yeah. Okay, so that's a front-end application. Now let's talk a little bit about front-end server and evolution. And previously, the traditional web structure is as below. We have a web server and the front-end, the back-end. When I'm talking about front-end, it's a front-end server. It's combined together, because in the code, in the previous, like you write a PHP, they are coupled together. All the business belongs to the front end, and the back end data server, the code are coupled, haven't decoupled. So in that kind of the traditional web structure, the web server receive a request from the web browser, and then they rendered a web page and download it to the web browser. So that means that it's rendered in the web server. The concept of this structure is that you have to reload the whole page from the server when even just a small change on your website, on your web page, when you hit a button. So this will lead to the bad user experience, because sometimes it updates the web page quite slow, spinning. So everyone has experienced that kind of spinning stuff on the web page, right? So that's because when the web server is busy, because of such a structure, they have more user requesting. They cannot handle at the same time. So that because of this drawbacks, someone come up with another evolution. It's called single SPA framework, means the single page application framework, such as Angular. It's from Google, React from Facebook, Vue from a guy from China. Okay, then there are. This is a structure of the front end plus back end server. It's a single page application structure. So now we have a back end server and the front end server. And then they decouple the business. The front end server is doing the web page stuff, and the back end is doing the kind of the API and the database and maintaining everything that sensitive kind of data stored in the server. For front-end server, they are when the user requests from the server, they download the whole web application to the browser. So the browser can render the whole page on locally. So that is called one page application. Later, when we start writing some code, you will see that there's only one page, which is the kind of like a index HTML, only one page. Okay, so the whole JavaScript language is supposed to render this one single page dynamically. Sorry. And when user hit a button on the web page, the browser go to the backend server to get the data, or post the data to the backend server, and it only updates a small portion of the web page if you design it correctly. So it don't have to update the whole page. So in such a structure, in such a design, and the web browser can update very quickly. Okay, so but in real projects, we do not directly connect to the backend server. We use in kind of like another kind of server, NGX server, to process our request to each whether when you it's like a front gate server. When you visit the if you send a request to visit front end server, then they send you request to front end server. And if you want to get data from the backend server, then they redirect your request to the backend server. This diagram is just for demonstration purpose. Okay. The cons of front-end application rendering. Okay. Now we know that we can update our page quite quickly, and the user is quite happy. The user is quite happy, but I don't think the web provider is happy, because when the SEO, like a search engine, hits their website, they get empty page, so that which means that their web page cannot get a high rank in the search engines ranking, so like a Google. So that what means that it doesn't bring much visitors to the website. So in order to satisfy SEO, search engine optimization is what it means. Okay, so people come up with another front-end server rendering. It means that, okay, so I want to satisfy the SEO. I need to get the rendering job from the browser to the front-end server, and when the user get a request, and then the front-end server render the whole page and download it to this browser. It looks like it's kept back to the old days, right? But it's a little bit different from the old traditional one, because it is the front-end server is still decoupled from the backend server. So when the front-end server wants some data, or they need to visit the backend server. Okay, so you might already realize that this will probably make the user unhappy, because the rendering on the web front-end server. So let's look at a little bit of the three type of rendering. So the traditional server-end rendering, it's a front-end, back-end is not decoupled, and the front-end browser rendering, then the front-end server rendering, the both front-end and back-end is decoupled. Now we realize that still no framework now on the market satisfy both users. One is a user that use the visit the website, and the other is the provider, or the web owner. They are not satisfied because their website is not ranked high in the search engine. So the search engine is not happy with this front-end browser rendering. Okay, so our solution is that we are going to use both front-end server rendering and front-end browser rendering. The certain pages for SEO are rendered at server end, the rest are rendered in browser. So this can make both users happy. Now let's talk a little bit about the languages that for backends. People in old days, actually internet is not very old. It's just like 30 decades, 30 years, maybe longer than that time. People used to use design backend, mostly use C++. Okay, C language, C++. But the concept of C++ is that it's a slow development time and requires much higher skills, and you need to be very careful with memories allocation and deallocation. Otherwise, it will lead to code. Your application will crash. Then later, people come up with a solution that they designed some kind of the engine that runs directly on the OS application, OS. So like the Xent, which is for PHP code. So normally this kind of engine is stable because it was designed and developed by experts of the teams who makes this engine very stable and multi platforms, like they can operate on Windows, Linux, all kinds of Unix, and also in Android phone and iOS phone. Okay, so the developer of a backend only have to write the PHP code to make the Xent engine happy. So so that it makes the design much easier and the design speed much faster. So PHP is not just one of that. There the JavaScript. Normally the previously JavaScript is only for the web browser, and then someone developed another engine that they front like it from the browser, Google browser, called Node.js. So Node.js can run on all kinds of servers. And Java also run on this virtual. I don't remember the engine for the Java, Python, and also Python. So these all languages are called high-level languages. They only running on some kind of engine. So they speed up, but the development speed is high, but the execution time takes much longer because you have to the Xen engine have to interpret this code and at the runtime to interpret it and run into the and compile into their code format. So the running efficiency and load time takes a little bit longer, but compared to that, when we design the project, there's always a trade-off. Why nowadays people like to use this PHP, JavaScript, Java, and Python? Because people kind of lazy. It's much easier to get your hands on the design, and also the development time is much shorter. And to overcome the efficiency of the engine and efficiency of the engine, the people can't, they can buy a little bit more the servers, and then to deploy it to run your application on more servers. Then you can come at these weak points of this engine. But the good point is that it brings the maintain time and the development time and updation time is very much faster for this project. If you are and nowadays a lot of engines are quite efficient as well, and okay, so that is the PHP, JavaScript, Java, and Python, and then there's another language come up, show up, that is called Golang. Go language. It's from Google, and it's kind of similar to C, but it's a procedural kind of language. And the plus is that problems of this language is that it's the compiled code is an executable file which runs directly on OS. So you can know that it's just like the same as a C++. But compared to C++, it's much faster to design. In this project, we are going to use both JavaScript and Golang to write two kinds of backend framework. And for Java, I use the existing framework. For Golang, I will try to develop our own framework. So it will be more exciting that you learn both, right? So you can switch from between the JavaScript and Golang, and to experience that how excited that how is the experience that you run your as your application on the OS directly, and one is to run it on Node.js. Maybe in the future you have a microserver, like you want to try your application on the demo board. Well, I guess Golang is a good choice for that, because it directly runs on the small devices, and they can fully utilize the hardware. Okay, now the backend request and response life cycle. And so when a user file a request to the backend server, the request router will do the matching to this handler function, the request to the handler function. But before you connect this request to the handler function, you have to go through several intermediate someone called it middleware, and someone called it plugins. It's just you can create as many as you want. If you see my project, it's just a function, and you find that point, and you can insert your function code, your function here. So now let's call it middleware as our plugin. So this first plugin is parameter verification. So it means that if your input request of parameters in your request does not match the format they request, they give a return and say it's wrong, and then the front end have to get the error. Also authentication. If they have to tell the backend server you are who you are, claimed, and then after the verification success admitted, then you go to authorization. Then are you the user that is allowed to access this handler function? Because this handler function have the access to the database, all kind of sensitive data. So when all these middlewares has been successful, and then your request finally go to the handler function. After you can also before you return the data from the database to the user, you also can do some post processing, like you want to hide the password. You don't want to send a password back to the user, because it's not safe to transfer in the network. And when we design the website, we know that the network is a untrusted system, and we are trying to do trusted system based on untrusted system. So safety is very important, right? That's why we need to encrypt every bit of our data transferred between the front end and back end, between user and front end and back end. So okay, so this is these request response general life cycle. So next time when you read a framework, they call it life cycle. You have an idea what is life cycle? It is just this. Okay. Okay. Now talking about frameworks. This is a backend framework. MCV is one of the backend frameworks. It's a old idea. So I don't recommend you to use this, because it's kind of confusing when what do you mean by controller? So I just want to tell you that what we have to like in the PHP a lot of PHP frameworks they use a lot of such kind of model, controller, and view framework. For the controller, they connect request to its handler function, and just this one you're matching this your request to this handler function. So and the model is dealing with the databases. So in the model, if item yeah, like your modems, yeah, product items and users. Each file, each folder have such a controller, model, and viewer. And viewer contains it's dealing with the page rendering. Like you have a CSS file and HTML file, and in HTML file you have find some variables you need to get data from. So there's some frameworks also add some functions to here too. Okay, so anyway, it's just what is framework? Framework just kind of like a pattern. Every team players obeyed, so we organize the code like this one. So when we design the huge projects, with scale projects, we can add up. We can divide these each modules to each member of your team. Okay, so also we should be able to write our own framework. Sometimes you will find that not all frameworks satisfy our project requirements. We need to be able to develop our own. So in this project, I'm going to show you to write our own framework with Golang. Here is a link to that. So in my project structure, I use this kind of structure, and we divide into models like a product, users. We don't use this MCV. We directly use handler, module, and router. In the router, we just like this one here. You just matching the router to this each row of this each router routine. Sorry, bad English. Sorry. Okay, so we're going to talk about this more. At least if I talk too deep into the details, it will frighten you, maybe get you confused. So anyway, I show you this on my. Oh, sorry, I don't have a network connection right now. And this is the GitHub. You can download these slices on my GitHub, and you can find it from my website, from this website. There's GitHub, the GitHub folder. Okay, so now let's talk a little bit about. Oh, sorry, I haven't translated from Chinese to English. It is a system diagram. Okay. The sensor media system diagram. I guess you will be very you will be familiar with this by now. So it's this structure is a peer-to-peer. That's the point. Peer-to-peer. That is all the things we want to achieve. Peer-to-peer. That is a very good idea. So we now we can have our own home server with IoT like systems set up for our home, and our cell phones will become just a remote controller and offload to the difficult jobs to home server and get back the data. Okay, if the network, sometimes if you are behind the firewall. Like in China, they have a big firewall around our country. So it's difficult. Sometimes it's difficult to get around the firewall, so directly to get access to devices behind the firewall. Firewall. Okay. So we have to fall back to the static our macro data center. Which is the front-end server. It's like a gate. A door to our home server. So we have fall back to this. But also, this connection is encrypted. That's much safer. Okay. So so any front-end device and back-end device can encrypt our message. Even this front-end server it's not able to encrypt the data we transferred between the home server and the back and this front end user. Okay, so that is the idea. Okay, IoT, and I think you know that Internet of Things for home device control. Internet of Things, IoT. Still a lot of Chinese here. Micro data center. Micro data center means nowadays the data center is in your mind. People will think, wow, that's a huge house with a lot of computer inside. But in the future, micro center will become dominating the market. I believe that. What is a server? What is server? As it says here in Chinese. Sorry, I'm translating. I'm a little bit lazy. What is server? What is data center? I mean, is a IP. It's a public static IP plus a server. What is server? Is a computer without a monitor, but that computer has a high performance. It's much expensive. But in the future, a group of people, a group of friends can together can rent a static IP or buy a static IP, and they share this server as well. So that they can afford such a server for their own non-commercial purpose. Like they just want the server to communicate with each other, so to communicate with friends. And because in the future, I believe that this is the peer-to-peer will dominate our social media system. For this kind of server, you can place this server at your your friend's home, and to act as a front-end server. Then they can transfer every data can transfer back to this place or to this place. In a front-end server, they can install several front-end servers in a one micro data center. One computer can behave like they can accommodate for several front-end servers, each one for different friends. Okay, so I hope you get the idea. Okay, and now in the future, trust. I mean, nowadays also trust is the most important criteria for a data center. But I believe the trust between friends is much easier to get. So even these people, you know that he's running a micro data server for the front end micro data center for front end servers. You will be more. You will tend to install your server install your front end server on their data center. Okay. For variety of reasons. One is a trust, another is short-routed. Okay. Okay. So I believe that if you have friends who are designing FPGA, I think that the device for the micro data center is a good direction. If I have time, I'm trying to do this. And I'm an FPGA designer. Actually, I'm an FPGA designer. I would like to consider to continue on this direction to design devices for their micro data center. Okay. So I really believe that in the future, not far away, I think micro data center will never be just a private gardens for big companies and big huge rich capitals companies with rich capitals. So I believe everyone has a chance and an opportunity to run the market data. Everyone can get a slice from this market. Cell phone is a remote controller. Well, as we see here. So no more to introduce this idea. I think free is not free of price. I think that so our privacy is more valuable and important. And the market of encryption, because as I said, the internet is an untrusted system. If you there's a lot of people aspects working in a high tech company that for encryption and decryption jobs. If this P2P market is dominating in the future, a lot of people will be at your service to design a lot of solutions for your front end and back end, even and your device and encryption and decryption solutions. I believe this is a huge market because there's a lot of need here. Different people have different type of security requirements. Security is not free, same as freedom. If I have such a device, I would rather to pay for a little bit some kind of money for this security service. Okay, so much for this for today's tutorial. Thanks for watching. See you next time.